So this is the answers to the 5.1 homework, and we're verifying identities. Now, I'm going to just work these out as I go. Keep in mind that I don't have these worked out ahead of time, so sometimes we might make a mistake or not get to the place we need and have to go back and start again. Let's go ahead and look at number 1. Now I see the left side looks a little bit more complicated than the right, so that's where I'm going to start. And I'm going to take secant and change it to 1 over cosine. So I'm going to have sine x times 1 over cosine x. Now sine x is like sine x over 1. If I multiply these fractions across the top and across the bottom, I get sine over cosine, which equals tangent, and that's what I wanted it to equal. Number 3, again, I'm going to start with the left side here. It looks a little bit more complicated than the right. Now I'm going to start with this tan negative x and use the even and odd properties and change it to negative tan x cosine x.
Chris Castellano, please call 5045. Chris, please call 5045.
Tangent is sine over cosine times cosine x. Notice these cosines are going to cancel, and we're left with negative sine x. And that's what I wanted it to equal. Number 5. Starting once again with the left side, let's go ahead and switch all of these. Tangent is going to be sine over cosine. Cosecant, 1 over sine. And I'm going to leave the cosine the way it is, but I'm going to rewrite it as cosine over 1. Now all these things are being multiplied together. So basically all the tops will stay on the top and the bottoms in the bottom, and I can do some canceling here. Sine cancels, cosine cancels, I'm left with 1. 1 equals 1. Number 7. A lot of ways you can do number 7. The route most people went in class was to change secant to 1 over cosine. Now over here it's going to be 1 over cosine as well, times sine squared. Remember that's sine squared over 1. So we get 1 over cosine x minus sine squared x over cosine x. And if I combine with common denominators, I get 1 minus sine squared all over cosine. Now 1 minus sine squared with Pythagorean identities equals cosine squared if you subtract sine squared from both sides. That's where you get that 1 minus sine squared equaling cosine squared. So I have cosine squared x all over cosine x, I'm sorry. And one of those cosines is going to cancel, and I'm just going to be left with cosine x. Now another method for this one could have been to factor out a secant, and you would have been left with 1 minus sine squared. Change that to cosine squared, and secant to 1 over cosine. And then again, you'll see that one of those cosines are going to cancel. So you could have also solved this one with factoring. Number 9. I'm going to go ahead and start with the left-hand side. I see on the right that all I want is sines left. So somehow I need to get rid of this cosine. And I know with Pythagorean identities that cosine squared is 1 minus sine squared. And I have a negative sine squared x and another negative sine squared x, so I have negative 2 sine squared x's. And that's what I wanted it to equal. Number 11. Let's go ahead and start with the left and change cosecant to 1 over sine. We'll leave sine the way it is. Now I want to combine those fractions, so I need common denominators here. So I'm missing a sine and another sine there. So I'm going to get 1 minus sine squared theta all over sine theta when I combine those fractions. Now, 1 minus sine squared is the same thing as cosine squared over sine. Now, cosine squared is like cosine times sine. Cosine times cosine. All over sine. This cosine times sine is going to equal cotan, and I'm still left with a cosine. All right. Number 13. Tan cotan over cosecant. Well, first off, I know that tangent times cotangent, these are reciprocals of each other. So let's change cotan to 1 over tan. Now when I multiply these together, these are going to cancel, and it's just going to equal 1 over cosecant. And 1 over cosecant equals sine. Number 15, sine squared theta times 1 plus cotan squared theta. So let's take a look now. 1 plus cotan squared theta. Let's look at our Pythagorean identities, and it looks like 1 plus cotan squared theta equals cosecant squared theta. So let's start there and change that one. Cosecant squared is the reciprocal of sine. So let's change that one to 1 over sine squared. And sine squared times 1 over sine squared equals 1. Number 17. Let's go ahead and start this one with the right side. Let's try that for a second. So I have 1 minus cosine squared theta. Now I know 1 minus cosine squared theta equals sine squared, using a Pythagorean identity. Now this is like saying sine times sine. And I know sine over cosine, if I just pick one of those, is going to equal tan. So now I get sine times tan. Number 19. Cosecant squared t over cotan t. All right. Now, cosecant squared t means cosecant times cosecant. And if I wanted, I could just put one of these over cotan t. Let's see where that gets us. Now right here, notice I have that first cosecant that I want. So somehow I need to turn this thing into secant. So let's see if we can do that. Let's just focus on that green circle for a minute. Cosecant is 1 over sine. Cotan is cosine over sine. Now remember, we still have that cosecant in front that we pulled out. It looks like these sines are going to cancel, and I'm left with 1 over cosine. And 1 over cosine is secant. Now remember, these are just one way to do these. There are also more than one way to do all of them.